One of the more interesting phenomena with waves is when two waves are almost the same frequency, we get something called the beat frequency. Piano tuners use this all the time. If you're tuning a piano string and you have a tuning fork, you play the piano string, you listen to the tuning fork, and when the piano string is near the tuning fork, you start to hear this sort of vibrations, like a wah, wah, wah. For example, let me play you an audio clip. Did you hear the beats in that clip? As the strings get closer together, the beats get longer and longer, and then you don't hear the beats at all. So as the two strings as the tuning fork and the piano string get further apart in frequency, you hear the beats getting more rapid. So when two waves are similar and close together, they kind of add up, and they kind of add up to big and then small and then big and then small. And in sound, that's volume or loudness. So when two sound waves are about the same frequency, you get this thing called beats. And as I said, piano tuners use that to figure out when the piano is exactly in tune with the tuning fork. Now it's very simple how it works. The beat frequency, if I have a tuning fork that's 238 Hertz and I have a tuning fork that's 240 Hertz, when I play both of them, I'm going to hear it vibrating with a beat frequency of 2 Hertz because there's 2 Hertz difference between those two. If I play a tuning fork with a frequency of 240 Hertz and one with 242 Hertz, the difference between those two is also 2 Hertz. So I'm going to hear a beat frequency of 2 Hertz, meaning it's going to vibrate louder and quieter 2 times a second. Now, if you notice this 240, if I played this tuning fork and heard a 2 Hertz beat frequency, I wouldn't know whether it was the 238 or the 242. All I know is that the other tuning fork is not in tune with it, and it's either 2 Hertz higher or lower. So for instance, if I had a 440 Hertz tuning fork, and I played it with another tuning fork, and I heard a beat frequency of 2 Hertz, what that means is this tuning fork is either a higher pitch or a lower pitch. Its frequency is plus or minus 2 Hertz. So what's the frequency of that tuning fork? It's either 338 or 442. 2 lower or 2 higher. How could I tell which one it is? I'd either have to know more information about this tuning fork, or when I listen to it, if this tuning fork sounds like a lower note, a lower frequency than this one, it's the 338 Hertz. If this tuning fork is a higher pitch than this tuning fork, then it's 442 Hertz. Let's do a problem that uses the actual formula for this now that we have the basic idea. In this sample problem, I've got 2 tuning forks. One's 240 Hertz, and I'm not sure the frequency of the other tuning fork. So I want to calculate what are the possibilities. I listen to the 2 tuning forks and I hear there are 6 beats in 2 seconds. So I have a formula now to do this, and it says the beat frequency, where's my chart? Oh, there it is. It says the beat frequency is equal to the second frequency minus the first frequency, the absolute value of that. So I'm looking for the second frequency. So I've got the first frequency, 240. So let's figure out what the beat frequency is first. Well, the frequency of that, I hear 6 beats in 2 seconds, so it's going to be the number of cycles divided by the time. It gives me a beat frequency of 3 Hertz. So I now know this number. It's going to be 3. And that is equal to the second tuning fork minus the first tuning fork. 240, the absolute value of that. When I get rid of the absolute value part here, I have to change this into plus or minus 3, because this could equal negative 3 or positive 3. So I say positive or negative 3 equals the second tuning fork minus 240. So there are 2 possibilities. This number here could equal positive 3. This number here could end up these numbers here could end up equaling negative 3. So the first one, positive 3 equals F2 minus 240. I'm doing the first possibility, and then I'll try the second one. If I take this 240 and I want to bring it over to the other side, I add 240 to this side, I add 240 to this side, I get 240 plus 3 equals F2. So F2 is 243. Which is easy to look at and figure out because this tuning fork is 240 and there's a 3 Hertz beat frequency. So really, I kind of already know this frequency's got to be 243 or 237. So let's see if it works out that way for the other one. This is the first case. The second case, I'm going to say -3 equals f2 minus 240. So I bring the 240 over to this side by adding 240 here and adding 240 there. 240 minus 3 equals f2. f2 equals 237 hertz. Don't forget your units. I can forget them, but you need to remember them for a test. So the answer is, this other tuning fork is 243 hertz or 237 hertz.